Welcome. Let's try this example. Here we have find the resultant on the force system shown. Based on the given data, we can see that these forces are coplanar and concurrent. It is because the forces shown F and this T right here, which is equal to per 100 pounds, forgot to write, and P, which is 300 pounds, are located in the same XY plane. And also notice that they meet at the origin, which is a single point, and thus we can say that it is a coplanar concurrent process. To find the resultant of this force system, we must first know what are the components of these forces, and after getting the components, take the square of each, the component in the x, component in the y, and then take the square root of it, then that's the resultant. So for the component of the force F, 390, we're given with a slope rather than an angle. To find the x and y components of it, we just basically use similar triangles. This is 12, this is 5, and if we take the square root of 5 squared plus 12 squared, this will give us 25 plus 144, that's 169, and the square root of 169 is equal to 13. And the other triangle is the triangle created by the force and its components. So as you can see, the Fx here should be negative since the direction of our force is towards negative direction. And the f of y should be positive. So to solve for the components x and y, we just equate the similar sides of these similar triangles. So we will have 5 is to negative 5 is to 13 is equal to negative f of x over f, and we know that the value of this f is 390. So we just change this f to 390 pounds. And so if we solve for the value of f of x, we will get negative 390 by 5 over 13 pounds. And for f of y, 12 is to fy. So 12 is to 13 is equal to positive fy over f, which is 390 pounds. Solving for fy, we have 390 times 12 over 13 pounds. So if we input that to our calculator, we will then get 390 times 12 over 13. This is our y component. And for our x component, negative 390 times, if you can remember, it's 5. The hypotenuse is 13, so it's negative 150. Negative 150 pounds and 360 pounds. Fx is negative 150 pounds and Fy is 360 pounds. And for our second force, T equals 400 with an angle with respect to the x-axis equal to 40 degrees. This is 400. We'll just use trigonometry here to get the components of this force T. This is T of x, in this case negative, since it towards negative direction, and our y-axis is negative also, so this is negative T of y also. We use cosine of 40, and basically it's negative T of x over 400. Negative T of x over 400 pounds. And the sine of 40 is equal to negative T of y over 400. Opposite over hypotenuse. And if we solve for T of x and T of y, will give us both negative 400 cos 40 for the x component, 400 cosine of 40, that's 306.42, and 400 sine of 30, 40, is equal to 257.12, and 106.42, 42 pounds, and 257.12, 57.12 pounds. So let's write it down. T of x and T of y. Negative 257.12 pounds and negative 306.42 pounds. And finally, we're now gonna solve for the third force, which is P equals 300 pounds. It's in the fourth quadrant, positive x and negative y, and is 30 degrees from the x-axis. This is P, which is 300 pounds. This is P of y, and negative since is negative y direction, and positive P of x. So the same process, cosine of 30 and sine of 30. For cosine of 30, it's P of x over this P equals 300 pounds. And for sine of 30, it's opposite over hypotenuse, negative P of y over 300 pounds. So P of x and P of y is just 300 cosine of 30 and 300 sine of 30, and negative 300 cosine 30 is gonna be 259.81. It's 259.81 pounds. And for the y component, it's negative, but sine of 30, it's negative 150. Negative 150 pounds. So P of x and P of y, positive 259.81 pounds, and negative 150 pounds. So that's it. We already have the components. If we check if it's correct, f of x is negative 150 because it's negative x towards negative x, and then positive the y component, then t of x negative and negative, p it's positive and negative. So to solve for resultant force, basically you just have to take the square root of the sum of the forces in the x component added to the sum of the forces in the y component squared. So for the f of x, we just add this all forces, negative 150, negative 306.42, and 259.81. So negative 150 plus, minus 306.42 and plus 259.81 all squared, and plus 360 negative 257.12 minus 150 all squared. So if we input that to our calculator, we should get squared plus squared, negative 150 minus 306.42 306.42 plus 259.81 plus 259.81, and then for the y, 360 minus 57.12, 57.12, and minus 150, so that's 202.18 pounds. 202.18 pounds. So this is now the answer for this question, finding the resultant of the force system, in which we get the magnitude. But if we are also to find the direction of this force, all we have to do is get the sum of this, and also for the y, sum of y and sum of x. So if we do that, I already stored answer plus c plus e. I will get 416.23, and I will store it again to x. That's now my summation of f of x. Then for my y, plus d plus f. So 467.12 for summation of y. And to get the angle that corresponds, or the direction of this, I just basically have to do arc tangent of y over x, or the summation of y over x, summation of x. That's gonna give me y over x 48.29 degrees, or 4.42. Oh man, wait. Sorry, 48.3 degrees. 0.3 degrees. So the magnitude of the resultant force of these three forces given, provided that the direction, the magnitude is 202.18 pounds, located 48.3 degrees.